Hello students, today I will teach you how to make a malware detection software or model by using machine learning and deep neural network. So in this task or in tutorial, we will make three algorithms. The first two are learning. First one is random forest and other one is logistic regression. And third one is deep learning neural network. So at the end, we will compare three algorithms and will select the best one. So first come to the dataset. So here is the link of the dataset. You can download your dataset from here, and I will provide the link into the description. And if we explore the dataset, you will find out that there are 41,000 original filed and 96,725 24. Those are malware files in the dataset. So here is the complete detail of the dataset. You can see the 5 sample rows, and here are the 57 columns of features that is in the dataset. And here's the complete shape, your dimension of the dataset, 1,38,000 something, yeah. And here's the complete shape of the original and the malware files. So in this task, our task is to deduct or classify that which file is malware and which file is original file. Okay. So in this data set, you will find out the last column whose name is legitimate. Okay. So in this column, there are only two values. One is 1 and other one is 0. So 1 represents the original file and 0 represent the malware file. So this will be our target variable in building the models. So here is again the detail of the dataset. We have all variables which are discrete. Here are complete rows. There is no missing value in this dataset, and the dataset 56 MB it contains. Right. So if you look on over the target variable, so we can see that the 0, which were the malware files, these are 96,000 something we have seen, yeah. And then 1, which were original files, there's something 42 and 45,000. So you can see that the our data set is imbalanced. So here's some pre-processing. I have pre-processed the data. Don't worry, I will show the code and I will describe complete code at the end. So here is the pre-processing. Here are the model architectures like random forest or logistic regressions and neural network. And here is the accuracy, and we will see these things in the code over code demo. So let's go to the code demo. So first of all, I have imported my libraries, required libraries. Yeah, the first one is Panda, which is used for the like deals with the files like CSV and the Excels, and the matplotlib is for the displaying graphs, and Cbone is also for that purpose, and NumPy to deals with the arrays. Okay, so here is the link of the data set. Okay, and here's the description, small description, and I have loaded here. I have uploaded my data set into the file, and it is separated by the this line. So here low memory true means that if you put this variable here, okay, it will not show, I think, all columns. Okay, so here is the sample of your data set. That is the sample file. You can see there's a 5 row only, and the name of the file is uh, it has the extension of exe, and here's the hash of one file, each and everything. So here are the other variables you can see in the data set, and here's the ending target variable, which is estimate. You can see the 111, yeah. So this is the sample of data sets. So further, if you go down here, you will see the file dimension, which you can see by by adding the dot shape with your data set, right? So remember, we have stored our data set in the mal data, right? And after that, the describe function describe your whole data set, right? Counting minimum, standard deviations, minimum, Q1, Q2, Q3, and maximum, and complete it is describing, okay? So after that, we are storing our target variable into the one variable. Here's the complete shape of the original and malware files. And here you can see the graph which you have seen in the slides. Yeah, complete 95,000, which are the malware files, and 45 or 42,000 something are the original files. So we know now it's time to clean the data set. So remember three things here. Yeah, the first thing, we don't need to convert or encode our data set, this data set. The reason is that our data sets was already in the form of numerical form. Whenever you just give input to the machine learning algorithms or deep learning algorithms, you need to convert your data set into the numerical form. Okay, if the data set is in another form, like the sentence, a string, or characters, if the data set is in the character or string forms, you need to convert your data set into numerical form. Okay, because machine learning or deep learning only understands the numerical values. Okay, so for that purpose, it is compulsory to convert our data set. But the good thing is here that our data set was already in the form of numerical form. Okay, and the other thing is here. Now the second thing is you need, which is important, that is the remove missing values. If you will not remove the missing values, so your model may perform poor. So this is second thing. So we have seen above that there's no missing values in the data set, right? So this is also a good thing for us. So the third thing is to select the features to remove unwanted or the column that we don't need. Okay. So here there were two columns. The first one is name. The second thing is MD5. So name was identical to each like row, and it doesn't give any sense in the data set, right? And MD5 was also the unique for each row, so it also doesn't give any sense in the data set. Yeah, so that's why I'm removing these two column from the data set. Okay, so after removing, so we found that our data set is already in the form of numerical. We don't need to encode. Okay, there's no missing values, and I have removed three values. Now our data set is now preprocessed. Preprocessed. Now it's time to split our data set and then build models, right? So here I'm using the sklearn library, which name is model selection, strand, test, splitting. Okay, so this is the sklearn library. So here you can see that there's a xtrand, xtest, xtrand. So I'm just saving the values. Okay. So this is the function. This is the function of sklearn, in which you will put your data set. Okay, data set, the input variables. Okay, and your target variable. Okay, which will be your target variable. So in our case, the last column, the legitimate, is our target variable, right? So here I'm giving the test size. The test size means 0.2, means the 20% dataset will be test dataset and the other 80% will be training dataset, right? So random state means the 42 is a number, yeah? You can change, you can set anywhere, anything. So you can see the training dataset shape, yeah? Here's the training dataset. You know that the 20% is over test dataset right now. Now it's time to build a model. The first model which I have built uh, is the random forest. So for the random forest, you need to import it first by using sklearn library. Here's the random forest classifier. And after that, for the evaluation, matrix, you will just import the make classification, right? So here here's the function of random forest classifier, in which, yeah, this is the I'm making the object of uh, this random forest model. This is the object. So in this object, I'm dot fit will fit with this model will fit on a whole data set in by using this function. Yeah, clf dot fit. So in this function, I gave xtrain. Okay, xtrain, this one. Okay. Then ytrain, this one, right? So means I'm giving the input variables here, the training input variables, and the targeted uh, training data set variables, right? Variable. So now my model is completely fitted here in the random forest. Now I'm going to evaluate my model on the training data set and then test data sets. So for that purpose, I have to import the F1 score, accuracy, confirm matrix, and okay, confirm matrix. So remember one thing here, yeah. You remember that over data sets was unbalanced, because unbalanced means that original files were few, I mean 45,000, and the malware files were more. So both were not equal. So if our data set is unbalanced, so we do not consider the accuracy as a accuracy matrix over evaluation matrix, because accuracy matrix does not uh, perform good, or it may be biased on the unbalanced data set. So we will here calculate the F1 score, which we can calculate, which is good for the, or I mean perfect for the unbalanced data set. Yeah. So here we have imported these things, this matrix, evaluation matrix, by using scalar. And after that, I'm going to evaluate my data model on the train data set. So here's the function random model. This was the random model. Okay. Um, Random model dot predict is the function in which you give your xtrand data set, right? This one data set you're giving here, but you are not telling which one is y. You're just giving the xtrand. You're not telling the y. So it makes some prediction here, and here's the function which is accuracy score. It will calculate the accuracy of the model, so in which you're giving your y train, which were actual y train, and the trend prediction, the model prediction you are giving. So actual, which was actual labels, and your model predicted labels, you are giving this function, and it will calculate the accuracy for you. So here is the accuracy of the random forest, that is 98%, right? So further, if we go down, so here I'm going to test my model on the test data set, the same. You give X test instead of extra. Here we give extra, and here we are giving X test. Okay. The model then make some prediction. So here is the actual Y level of the test data set. Is the prediction of the model, right? We are giving to the accuracy score, and the accuracy score is returning 98% accuracy of the on test data set. So we can see that this model is performing outstanding. Okay, so here is the time to calculate F1 score. Same in which in this function you will give F1 score. Let me zoom. Sorry for that. Okay, I think this is better. Okay, F1 score. So same y test data, the predictions of the model. So these were the prediction, right, on test data, and you will give the 97 accuracy, 97% accuracy you are getting here. Okay, and now F1 score you 97%. So it's mean that this model is performing outstanding. So now it's time to check out the confusion matrix. Here is the complete code of the confusion matrix. You can just copy and paste this code. It's a little bit tough. It's a little bit difficult, but just copy paste it. Yeah. Here's the just title option. Yeah. Here's the function in which I'm just giving my model name, X test dataset, Y test dataset. There's a function to display it. Okay. So there's a function to display it. So here's the confusion matrix. Okay. And here's the confusion matrix in a graphic in a good way, and it's This is also good. Normalized confused matrix. So let's see this confused matrix. So in this confused matrix, these two values are very important for us. If these values are more as compared to this one, so of course this model's performance good, but we need this value much lesser in our data set, right? These are the this one is false positive and false negative. Okay, if these values are more, it's mean that our model is not performing good. Okay, so but these values are fine for this model. Let's see to the other models what is the confused matrix shows. So this one shows that 99% and 99.7%. So 99% means that the file was actually the original file, and our model also said that this file is original. Yeah, on the test data set. And if you see in this 97%, it shows it is telling that the original files was the file was malware, and our model also said that this is the malware. Okay, so if we check this one, so it shows that the file was negative. The file was means that the malware, but the model said that this file is original file. Okay, so it is the opposite of this one. So we can see that these values are so less, so it's best. So it means that this model is performing good. So here's the logistic regression of a second model. We are importing no, this is now for this. Okay, I'm removing it. Sorry. Okay, this one is the logistic regression. I'm just importing it here again. I'm making the object of this one, and then I'm fitting the logistic regression by giving the X train and Y train, and the same way you will fit your model here. And after that, here's the time to evaluate. Just ignore this warning. Ignore it. Yeah, just ignore them. So here is the model evaluation on the test. First of all, on the train dataset, training, X-train. Again, the similar way we have done above, like model, object, and prediction on X-train. Here you will calculate. Here it will calculate the accuracy of the model by when we give the actual Y labels and then the training prediction. Right here we give the we got the 70% accuracy. In the same way we are calculating here F1 score. We got the 69% F1 score. No, not F1 score. It is the evaluation on the test data set, right? So we got the accuracy on the test data, which is 69%, and then we have calculated the F1 score, which is 0, 0. Yeah, it means there's a problem in this model. It's not performing good because the data set was unbalanced. So logistic regression, I think it's not performing good in this kind of data set. Okay, so let's move to the confused matrix, the similar code. Here you just need to change these things as well here. So you will get this confused matrix, right? So this one is the confused matrix of logistic regression. Is mean that this model is performing poor on the dataset, right? Because this thing is 0, it's mean this is poor. So this value is more 8,000, right? So if you go to the next neural network model, so here you will import the TensorFlow, and here you will use the from TensorFlow Keras model. This one sequential model, and here you will import the Keras layers. Okay, so we are importing the dense layer. Dense layer means all means connected layers. Okay, every node will be connected to each one to the next layer. Okay, means dense means completely connected. So here is the simple architecture of the our model, neural network model. So first of all, you will declare that our model will be sequential, means in a sequence form, right? So after declaring it, you will add the layers in the model. Like, look at this one, this whole diagram, right? So you have declared that our model is sequential. Now you are going to make the layers. Okay, the first layer is here, second layer, third layer, and the fourth layer, right? So in the same way, the 16 nodes are here in the input layer, and then the 8 layer, and the 4 layer, and then 5 layer. And here's the or activation function is relu, and the last one is sigmoid, which is the output layer. So this one is input layer, this first one, yeah, right, this one, and this one is the output layer. So here, the modular summary is providing us complete summary of the our neural network model. So after making the architecture of the neural network, it's time to make the it's time to compile our neural network. So in compilation, um, we give three things to the model compile function. The first is loss, which one is binary cross entropy. Okay, optimizer will be optimize our model. Okay, that is the RMS prop, and the matrix means which thing you need in the evaluation, right, during training, right? So we need accuracy. So means while training we will see the accuracy of the model, that it is increasing or decreasing, yeah, and we will also see the loss of the model, right? So I have trained this model on the 5 epochs. 5 epochs means iterations, right, in complete data set, and then training, x train, and then I'm giving y train, and batch size is 32. So in neural networks, it's not a complete architecture that you just wrote these lines and then neural network will start performing good. No, you have to change your parameters and then perform some experiment on the neural networks. For example, here's the batch is 32. Okay, you can change it to the 65. Okay, 120, 180, whatever you want to put here. Okay, your 1000 you can put you it's your work to perform multiple experiment on 32. When you put here 5, 10, 500, it up to you, okay. So it's all about the experiment and hyper and parameters changing. So I gave these parameters, and it's, you can see here that the loss is reducing 22, yeah, and the accuracy is just 75, and then it just reaches 94%, right? So here's the time to evaluate it. This one on the trend data set. It's the same. The model, they predict. I'm giving trend data set. It is giving me some prediction on trend data set. So remember one thing: neural network. Uh, Neural network gives us the value in the two form, right? No, not true form. I mean, in the form of decimal form, 0 0.1, 0 0.2, 0 0.3, yeah. So if the here's the line, it is showing that if the value is greater than 0.5 or 0.5, then you will consider it 1, and if the value is less than 0.5, you will consider it 0. So that's why this function is just checking these things, okay. And again, I'm giving this predictions and the actual training into the accuracy matrix score, and you will get this 95% accuracy on the training data set. But if you look at in the testing data set, we will get the 95% accuracy, the same, yeah, fine. Means this model is performing good, but the our data set was unbalanced, okay. So we are not considering this accuracy our final evaluation metric. We will consider the F1 score. So remember that it's remaining. So here is the simplest function of scalar to calculate the confusion matrix, okay. So if you have trouble in understanding in the above code of the confusion matrix, it's okay. You can simply add this function here and then give to the actual labels of the test data set and the predicted levels of the test data set. So you here will be the confusion matrix, the simplest confusion matrix. Okay, so now it's time to calculate the F1 score. So F1 score is the here's 91%. Okay, there's a huge difference between the 95%, 91%. So it's mean that this data set is not, yeah, the data set was unbalanced, and we will consider the F1 score. Yeah, this one. Now let's compare the overall the performance of the model. If you look at the performance model, right? So the random forest with 98% test data set with not with F1 score, that is one is 97. So we are considering F1 score, 97% F1 score of the random forest, 0% logistic regression, 91% that is the neural networks. Okay, so it's mean that the random forest on the number one. Okay, so why? There's a reason why neural networks are is not performing good here. The reason is that the neural network needs a lot of data set. It doesn't work on this small type of data set. For example, it does not perform good on the few MB data set or few rows. Okay, it needs data set in the GPs or 100 MBs. Okay, if the data set will be more, then neural networks will perform good on more data set. So that's why neural network is not performing good in this kind of task. So yeah, so it's okay. We have the machine learning algorithms which are performing well on this kind of task. Okay, that's fine. There are many challenges, yeah, in this kind of task like malware detection task. Challenges are that you don't have the enough accurate data set. I mean, real world data set of the malwares. The reason is that companies do not share data sets. It may be because of the Protection Act, Data Protection Act, or maybe because they don't want to share their sensitive information. It's actually some sensitive information. So that's why they don't share publicly. So you don't have the advanced data set, right, to make a perfect malware deductions. And one more thing is that the malwares are growing. They are making themselves complex every day, so advanced to target to attack any computer system. So in order to tackle those advanced malware softwares or viruses, you need advanced data set, advanced techniques, okay, to save your computer from them. So these are some challenges here in this kind of problem, malware detections. So thank you. If you have any question, just write in the comment box. I will upload the data and the data link and the actual code and everything soon. Yeah, but not now, but soon. You have few days, right? Sure. So if you have any question, write in the comment box and share your views and share your result if you're going to make if you have made any model or any something on the malware detections. You can share in the below in comment box. Thank you so much. Thank you so much.